Two cells each of 5 volt are connected in series with a 8 ohms resistor and 3 parallel resistors of 4 ohms, 6 ohms and 12 ohms. Draw a circuit diagram for the above arrangement. Calculate 1. The current drawn from the cells. 2. Current through each resistor. Let us look at the diagram. This simple circuit diagram. Epsilon 1, epsilon 2 each of equal to 5 volt and the value of R1 is 8 ohms and value of R2 is 4 ohms and value of R3 is 6 ohms and value of R4 is 12 ohms. These are all the given value. Good. Let us solve the problem. Before solving the problem, keep it in mind, to determine current and potential difference across the resistors, make the circuit smaller, still smaller by reducing resistance in series or parallel. And then return, keeping in mind that in series current is same and in parallel potential is same. Good. This is a circuit diagram. Solution. Look at the circuit diagram. Epsilon 1 and epsilon 2 are in series. Therefore, epsilon, the total EMF, epsilon equals epsilon 1 plus epsilon 2, 5 plus 5. So, epsilon is 10 volt. The first data, the first answer. Okay, we reduce that into one cell now. Look at here, R2, R3, R4. They form a parallel connection. 3 resistors, R2 equals 4 ohms, R3 equals 6 ohms and R4 equals 12 ohms are connected in parallel combination. 1 by Rp equals 1 by R2 plus 1 by R3 plus 1 by R4. The value of R2, R3 and R4 are substituted. R2 as 4, R3 as 6 and R4 as 12. Now 12 as common denominator. Then on the numerator we have 3 plus 2 plus 1. So we get 1 by Rp equals 6 by 12 equals 1 by 2 Rp equals 2 ohms. Good. This is a second answer. We reduce that into a single resistance now. Look at the circuit diagram. R1 and Rp right now they are in series combination. Rp equals 2 ohms and R1 equals 8 ohms are in series. Therefore, the total resistance Rs equals R1 plus Rp. Substituting R1 as 8 and Rp as 2 ohms, we get Rs equals 10 ohms. Let us write that. Good. Now, these two resistance becomes 1. Then, the potential difference across Rs equals EMF of the cell since the internal resistance is negligibly small. The current drawn from the cell Is equals epsilon by Rs. So, Is equals the epsilon is 10 volt whereas Rs is 10 ohms equals we get 1 ampere. We write that. Now, we are returning back to the original circuit. The one resistance right now become 2 resistance. Good. Potential difference across Rp equals V2 which is equal to Is into Rp. We have found Is as 1 ampere, Rp as, look at Rp as 2 ohms. We already have this data. So V2 equals 1 into 2, 1 ampere into 2 volt. We get V2 as 2 volt. When epsilon is 10 and V2 is 2, definitely V1 will be 8 volt. V1 equals epsilon minus V2. V1 equals 10 minus 2. V1 equals 8 volt. Good. Now, that one Rp becomes 3 resistance right now. We are returning. Current through R2. I2 equals, the potential is same now. V2 by R2. V2 is 2, R2 is 4 ohms. Good. We get I2 equals 0.5 ampere. Current through R3. I3 equals V2 by R3. equals 2 by 6 equals 0.33 ampere. Current through R4. I4 equals V2 by R4 equals 2 by 12 equals 0.17 ampere. We have got all the data. Thank you, children.